Hi everyone, this is Oscar Eduardo Guillén Ortiz, a student from Arkansas State University Campus Querétaro, and I'm going to present to you my project for Space Physics 1 course, which is about life and water on Mars. Welcome to my video and I hope you enjoy it. When my physics professor first told me that I had to make a 15-minute video talking about life and water on Mars, I was super scared. I thought I was going to fail the course with a 20-second video saying that there was no life and there was not water on Mars. However, after researching for a while, I found out some interesting research papers which gave me information and proved me wrong about what I thought before learning about this topic. There's a lot of revealing information about life and water on Mars. However, since I'm not a scientist, not an astronomer, not a cosmologist, not a mathematician, I'm going to try to explain you these research papers I read in an easy and friendly way, but it's important to mention that I'm only going to make emphasis on the ones I found more important or more relevant about the evidence of life or water on Mars. You might be asking why do I have a basketball in my hand since the beginning of the video, but let's think about this. This is Mars, and this is the Earth. And right now, the Earth has a lot of water on it, and Mars doesn't have any water on its surface. However, this might have been different a long time ago.
First of all, I want you to look at this image. It really looks like Earth, but it's not. It's Mars from a long time ago. NASA scientists have determined that a primitive ocean on Mars held more water than Earth's Arctic Ocean, and that the red planet has lost 87% of the water to space.
Although the surface of our red planet is right now super cold and super dry, there's a lot of evidence which suggests that our red planet was once partly covered with water.
The images I'm about to show you are obtained with the help of the MRO, which is the Mars Reconnaissance Orbiter, and it is a spacecraft specifically designed to study the geology and climate on Mars. It provides recognition of future landing sites and relay data from surface missions back to Earth. Researchers have detected signatures of hydrated minerals and slopes seen as dark narrow streaks on the red planet. They appear in several locations on Mars when temperatures are above -10 degrees Fahrenheit or -23 degrees Celsius, and disappear at colder times. We can see them in this picture, for example. These downhill flows, known as recurring slope lineae, RSL in English, often have described as possibly related to liquid water, and these are found in northern sites such as Valles Marineris, although certain hemisphere sites also host them. A 2016 paper suggested that RSL are driven by tiny amounts of brines or salty water mixed with soil. Salt lowers the boiling temperature of water, helping it stay liquid even on Mars. These recent findings also suggested that less water is needed to create RSL than previously assumed. Moreover, this water may be very short-lived, and therefore not an ideal environment for any microorganism that may exist on Mars. NASA's MRO allowed us to see the first spectral detection that supports liquid water formation on today's Mars and to prove the hypothesis of RSL. It provides the strongest evidence yet that liquid water flows intermittently on present-day Mars. There's still a lot of uncertainty about RSL. Many researchers refer to it as liquid water, but as mentioned before, these are just hydrated salts and not liquid water as we know it on Earth. This image from NASA's MRO also captures a group of layers bound by sudden changes in the material present on the surface. These structures may have formed as water flowed across Mars' surface, creating this land relief. From this, we can see evidence that water flowed on Mars back in the day. The best place to find significant amounts of water on Mars may be the subterranean aquifers. Analysis of Martian meteorites such as NWA 7034, the image you can see right now, Martian rocks that landed on Earth after they were blasted off the red planet by cosmic impacts are a hint of aquifers in the Martian crust. Since Mars has a surface gravity of little more than 1/3 Earth's, its crust is less dense and more porous than the one of our planet. Research suggested that this means that more water can leak underground Mars surface, but since there were not official findings, there was speculation that these were not shallow aquifers, and that these subterranean aquifers may reside miles or kilometers below the surface. From these speculations, and considering the images we have of the north and the south poles of Mars which have ice, it was just a matter of time till we had new information or new findings about layers of ice on this planet. In 2015, scientists discovered that a giant slab of ice as big as California and Texas combined is buried just beneath the surface of Mars between its equator and the north pole of this planet. However, that was just the beginning of the story. On 2019, a paper called Widespread Shallow Water Ice on Mars at High Latitudes and Mid Latitudes was published in the journal Geophysical Research Letters, and it revealed a new map based on data from two long-running spacecrafts which were NASA's MRO and Mars Odyssey. Each spacecraft used heat-sensitive instruments to find the ice, since ice changes temperature of the surface of the planet. This map shows where the underground water is located on Mars. Cool colors represent water ice that is closer to the surface than the areas in warm colors, and black zones indicate areas where a visiting spacecraft will sink into the fine dust of the surface. This research team not only confirmed and showed us the precise location of the ice on mid-latitudes of Mars, but also located at least one promising land spot for future astronaut missions, a big zone in the northern hemisphere's Arcadia Planitia. On a paper released in 2018 named Radar Evidence of Subglacial Liquid Water on Mars, announced that Mars might be hiding a lake beneath its southern pole. Roberto Orosei, principal investigator of the Marsis experiment, mentioned that this subsurface anomaly on Mars has radar properties matching water and water-rich sediments. However, not all researchers are as certain about the experiment of liquid water. Thus, we cannot conclude that this is 100% true. Steve Clifford, a Mars researcher at the Planetary Science Institute in Arizona, said that there's always the possibility that conditions that we haven't foreseen exist at the base of the cap and are responsible for this bright reflection. It is very persuasive argument, but it is not a conclusive or definite argument, he mentioned. Before moving into talk about life on Mars, I would like to mention this last article called Scientists Map Water Vapor in Martian Atmosphere. It is by the Moscow Institute of Physics and Technology. The research includes observation of seasonal variation in atmospheric concentrations using data collected over 10 years. This is the longest period of observation and provides the largest volume of data about water vapor on Mars.
Right now, the surface of Mars is really arid, and it doesn't allow the water to flow on its surface. All of this is because it has a really thin atmosphere, which doesn't allow the liquid to stay long on the surface. With so little air pressure, it evaporates from a solid to a gas. This is because the atmosphere is really thin, and it doesn't allow water to stay on the surface for long periods of time. However, there's clear evidence that I showed you already that scientists and researchers have, and they can prove that water did flow on Mars back in the day. Researchers also mentioned that this happened only because the atmosphere of Mars was thicker back in the day compared to the atmosphere it has right now. I'd like to mention what's the theory about how this planet lost its atmosphere. This planet started to lose its magnetic field because of its size. Compared to the Earth, it is smaller, so it started cooling down little by little. Then, after losing its magnetic field, and it's a process that we still don't know 100%, we're not 100% sure that it happened that way, then it started to lose its atmosphere. The atmosphere started to go to the poles and to the soil, and because of its small size, once again, it couldn't hold down its own atmosphere as a planet. This is why Mars now has a really thin layer of atmosphere. This process continued happening until the planet could not be holding any water flowing on it anymore. There are three states of water: solid, liquid, and gas, or ice, water, and vapor water. Now, with the information I showed you, we can conclude that there's water on Mars. Maybe not on the liquid phase, but there's ice and there's vapor water. So yes, we can conclude that there's water on Mars, and maybe in the long run, or maybe in the next years, we can see if the lake that was supposed to be underground, it is there, and if it is there, we can conclude that there's also liquid water on the red planet. Now that I finished talking about water on Mars, I'm gonna start talking about life on Mars. I want to make sure that we're not gonna be talking about this kind of life on Mars, even though it will be cool, and I would like to see topics like that. This is not the information I found. If we're looking, or the scientists are looking for life on Mars, they're just looking for microorganisms, since if there were these kind of aliens just walking around Mars and partying and cooking like we live here on Earth, it will be easier to find them. I'm gonna start to explain you some of the most relevant evidence, theories, or speculations about life on Mars, and I hope you enjoy it as well. For us, water and life is related. If there's no water, there's no life. This is why scientists tend to look for water on other planets so we can see if there's life as we know it on these planets. So it's the same in the case of Mars. But what are we looking, or what are scientists looking when they look for life in other planets? NASA defines life as a self-sustaining chemical system capable of Darwinian evolution. It is important to see this definition because this is what scientists are looking for in other planets. This definition, or this process, is supported by water. This is why it's that important to look for water in another planet, because if there's water in another planet, it's very likely to have life.
Some scientists contend that signs of life were already found by the first American lander to touch down on the red planet, Viking 1. It landed on Mars in 1976. Viking 1 performed a life detection experiment that many scientists agreed did not uncover life. While some researchers mention that NASA's Viking 1 proves the first evidence of life on Mars, some scientists, and even NASA, mention that it found no traces of life, and it only helped to better characterize Mars as we know it. Viking 1 measured no significant amount of organic molecules in the Martian soil, and some scientists mentioned that the instruments used on Viking 1 weren't sensitive enough to do the appropriate experiments and draw clear conclusions with the information obtained. Earth's diverse residents advertised their presence in obvious ways, and advanced alien civilizations could probably figure out pretty quickly that our planet has life on it just by scanning our atmosphere. However, we don't see any such clear-cut evidence in the Martian air, but scientists found out an intriguing hint. More than 90% of Earth's atmospheric methane is produced by microbes and other organisms, so it's possible that the presence of this gas on Mars is a signature of modern life on the planet. But the jury is not completely on this side. Abiotic processes, which are processes with no life involved, can generate methane as well. And even if Mars methane is biogenic, the creatures that created it could be long dead. There's a project called Search for Extraterrestrial Genomes, which is developing an instrument to detect past or present DNA or RNA that could be present on Mars. This DNA or RNA are the nucleic acid that contains the genetic instructions for the development and function of living things. This research relies on the panspermia principle, and it is the idea that life has spread widely throughout the solar system, so if life did indeed came to Earth, there's a good chance it once flourished on Mars as well. MIT researchers are currently developing a biomarker-seeking instrument which analyzes Martian dirt to uncover genomic information left behind by microorganisms that died out up to 1 million years ago. This will be possible as genomic information could last much longer because of the cool, dry environment in Mars. The tool should be able to detect signatures of DNA and RNA on Mars and will need hospital-level sterilization for any rover attempting a life detection experiment. The principle they use is that if there was life on Mars, it may have moved around, it may have gone into hiding a bit, but it's probably still there. NASA's 2020 Mars rover is scheduled to launch on this summer, and it will hunt for signs of long-dead red planet life. So will the European Russian ExoMars rover, a mission that will lift off at about the same time.
Unfortunately, to this day there's no proof that can tell us, look, there is life on Mars, or there was life on Mars. But bringing back the topic of water on Mars, since we know there was water flowing on Mars back in the day, maybe there was life on the planet, we just have to find it. Or considering that now there's ice, there's water vapor, maybe there is life there, but we haven't found it. But these are just speculations. Or in the future, if we found a ground lake, the one I told you before, maybe there's life on the planet. But as I mentioned, these are just suggestions or speculations. No, unfortunately, right now, there's no life on the red planet.
Even if life no longer lives on Mars or never existed in the first place since we don't have any proofs, water could allow future life on Mars in the form of human colonies on the red planet. Maybe, in the future, we will be the living organisms in the surface of Mars.
Thanks a lot for watching this video. I had a great time researching about these two topics, so I hope you enjoy watching and learning about them. Thanks once again, and bye bye.